Hi all, in today's video we're going to cover the cosine functions in trigonometry. So unlike the sine functions which you've covered in the previous video, the cosine functions are a bit different, but the concept is exactly the same. It's just that the shape of the function is different. So if we look at the cosine function, it's written in the form f of x is equal to cos of x, where x is a function of, or is a variable that is a function of f of x. In other words, if you substitute x, you'll get the y value of this function. Okay, so if we have to draw it on the Cartesian plane, we have a rather different shape than we did with the sine function. Now here we have 1, we have 0, we have -1. The cosine function has the same period, which is 360, unless stated otherwise. This is how the cosine function looks. It looks like one big smile. At this point, it's where it ends, which is our period of 360. And then at the center of it, you guessed it right, 180, because it's half of 180 is half of 360. And then this point is 90 degrees. And then this point is 270 degrees. Okay? So the amplitude of this function is still 1. Alright? Or rather, it has one turning point, which is the minimum one. Okay? And then the amplitude is still the very same distance from the center, or from the x-axis, to the lowest point in this case. Right? And then one other thing to note is that the period is still the same. Remember, f of x is equal to cos of x. So the period is just going to be x is equal to 360. Okay? And then the same applies if we were given cos of 2x is equal to 360. Our function will be, our period will be x is equal to 180, because we're just going to equate 2x with 360. Then we divide both sides by 2 and we get 180, which will give us our period. Okay, so as much as the cosine function operates the same way as the sine function, we're still going to touch the most basic elements in it to understand it on a deeper level. Now, if we're given, or if we're interested in shifting this graph to the left or to the right, we're still going to add the angles that we want. So it's going to be cos of x plus or minus whatever the shifting amount we have. I'll call this one P plus or minus Q, where Q is upward or downward shift and P is left or right shift. Okay, so let's start with shifting it to the left or right. Okay, so let's say in a question we are given, or we are asked to draw f of x is equal to cos of x. Let me write it down here. Let's say we are asked to draw the function cos of x minus 30 degrees. Alright, which is our function f of x. Alright, so the first thing that we'll do is we will construct our Cartesian plane. This is our 0, or this is our origin. I just drew the right hand side part, or the right part of the Cartesian plane. Okay, so obviously this is the positive side, this is also the positive side. Okay, so you know, our cosine function will look like this, and then given that here it's 360. Okay, and then this is 1, this is 1, this is -1, which is the lowest point, then this is also 1. Okay, so now we are asked to shift it to the right by 30 degrees. They won't tell you it's the right shift. You just have to know if it's x minus something or minus any angle, it's to the right. If it's x plus any angle, it's to the left. Okay, still counterintuitive as we have had with the sine function. Now we know this is 180, this is 90, this is 270, and this is 360. So if we want to shift it to the right by 30 degrees, we're going to add 30 to every angle that we have. So instead of it starting at this point of 0 and 1, it's going to start at 30 and 1. So it's going to start here. Now, instead of it cutting at 90 and 0, it's going to cut at 120 and 0. So it will come here. And then instead of the graph turning at 180 and -1, it will turn at 210, 210, and -1. So somewhere here. Just want to remove these points that I don't need. So I will erase these unnecessary angles. So just to construct how far we have come, so I don't lose the track, we're going to have these points. Then it's going to turn here. All right. So instead of the graph cutting at 270, it's going to cut at 300. And then instead of it ending at 360, it's going to end at 390. So somewhere here. Same point, we have 390 and 1, which makes our x and y intercepts. Okay, so I will not touch the shifting up and down because it's exactly the same. You're just gonna add 1 to every y-intercept of this function. You know that the y-intercept of first point is 1, then you have 0, and then you have -1, and then you have 0, and then you have 1. So you're just going to add 1 to every of this point if we ever have to shift the graph by 1 unit upward. The same applies if we had to move it downward. I want you to notice something. Now, this involves both sine and cosine functions. So, if we're given a sine function like this, and we're given a cosine function, I'm just going to draw this as f of x and then our cosine function will be one, and then here is 90, and then here you have 270, and here we have 180. Okay, and then this is where it ends, also at 360. If we're given a functions like this, and then they ask you to talk about the domain and the range of these functions. So the domain is a set of x values in which our function span, okay, or covers. Range is a set of y values our function span or covers. Okay, now if you look at this function, if we are interested in finding the domain of sine of x, right, we know that our domain is going to be 0 to 360, okay, which is our domain. Okay, and then the same applies for the cosine function. It starts at 0 and ends at 360. It makes our domain. Domain is from this, where the function starts to where it ends. Okay, all of them are starting at 0 to 360, both of these functions for now, or if they're given in this way. All right, now if we're interested in finding the range, we look at the y-intercept, or we look at the y coordinates in which our function covers. Now let's start with the sine function. So our y, or our function, highest point is at 1, lowest point is at -1. Okay, so if we're interested in finding its range, we'll say -1 to 1. This is a mathematical sign, which means y is an element of -1 to 1, where -1 is the local range, or rather the local turning point, and the 1 is the maximum turning point. This is minimum, this is max. Mean, max, turning points. Okay, so we know that the range of these functions is 1 to -1, and the domain is from 0 to 360. But now, what is also more interesting about these functions is that we have a turning point at 180, and this one has, the cosine function has only one turning point, and then the sine function has two turning points, which are at 270 and 90 degrees, as well as the cosine function, which is the orange one, being at only 180. Turning point is where this function turns, or it's called a stationary point. Okay, and then you will notice that from 0, looking at the cosine function alone, you'll notice that from 0 to, I'll call this point A. So from 0 to A, it's positive. Where I'm saying it's positive, it's concave down. It's looking downwards. And or rather, it's sloping upwards. So that's why we're saying it's positive. And then at A, it's 0. right? And then from A to B, it's negative. It's negative. It's negative. From A, not exactly at B, because at B it's 0. So to A, from A to almost B, it's negative. So if we had to write the range of A to B, it will be from A, it will be from A, so X from A to B. So at this point, or at this, our function is negative, or X is negative at this point. It's negative. So if they ask you to give us to give us the domain in which your function is negative, then you're going to give them this one. You're going to give them this one. It's where it's negative. Okay. And if they ask you to give them the domain in which this function is positive, you know this function is positive when it's concave up. So if you check at this point, it's sloping upwards. So it's positive. So this is positive. This is positive. This is negative. Okay. So if they ask you to give them the domain in which this function is positive, you're going to give them from A, from 0 to A, and from B to 360. So positive from 0, X, to A, and then X from X is greater than B. These are the points in which this function is positive, or domains in which this function f of x is equal to sin x is positive. Now let's look at the cosine of x, which is the orange one. We want to look at the domain and the range and the points where it's negative and the points where it's positive. Okay, so now coming back to our cosine function, we know this is 1, this is minus 1, this is 0, this is 180, this is 360. Okay, this is our x and y intercepts. This is 90, this is 270. Okay, now let's look at the dynamics of cosine function. F of x is equal to cosine of x. Okay, now when you look at this function, it's negative. Let's call this point A. We know at this point it's 0. Okay, so now it's negative from here. This is negative, but from here, because it's sloping upwards, it's positive, or the gradient is positive here, even here. So if you look at this function, if you're asked to give the domain in which this function is positive, domain is a range of x values in which this function is negative and positive, you'll give it this way. We'll give it this way. F of x, or the domain from 0 to not a, but less than a, our function will be negative. This is negative, negative, negative. And from a plus x is greater than a, our function will be positive. And x is equal to a, it's going to be 0. This is the most important part because this is a turning point. Okay? Now, some questions you may come across who look like this. I want you to observe this very carefully. Here, we have two functions. This is your x-intercept. This is your y-intercept. Or rather, your y-intercept. Okay, I want you to observe this very, very carefully. So, if they ask you to give them the points in which sine, let's call this sine function f of x. Let me change this to red. And then this h of x. Now, if they want you to give them or to identify the points in which f of x is equal to h of x, you're going to look at these points. So if they're looking for equal, you're going to look at the points in which the function cross each other, or point of intersection. It's where f of x is equal to h of x. Let's look at them. So, look at these graphs. Where do they cross each other? Here and here. These are the points of intersections. And how do you find them? It's easy. You just equate these two graphs. You say, well, f of x is equal to sine x is equal to cos x, and then you solve. You know, you divide both sides by cos x, then you get tan x is equal to 1, and you solve for x. The idea is for you to understand that at this point these two graphs are exactly the same, or the coordinates of these two graphs are exactly the same at these 2 points. Okay? Now, if they ask you to give them the points or to identify the points in which f of x, which is our sine, it's greater than h of x, you're going to look at the points in which f of x is at a higher point than h of x. For example, if you look at this point starting from 0, sine of x or f of x is underneath h of x. So we are only interested in the points in which f of x is in which h of x is underneath f of x. So this is the point. So you can see that at this point h of x is less than f of x. Okay? This is the only point. And then to know the domain of this point, you have to know the coordinates of this point. Let me call it A and B. And then you know that at this point, h of x, or rather f of x, is greater than, you know that f of x is greater than h of x. Okay? And then once we know the points A and B, we know that our values will be x will be this is what they're looking for. This should be your answer. Once you know A and B, you'll be able to know the points in which f of x is greater than h of x. The same applies if they said f of x is less than h of x. You know f of x is less than h of x, right? F of x is less than h of x. We know we're looking for these points in which f of x is underneath. Less means underneath, right? F of x is less than h of x is this point. From 0 to a, and then let's look at another point in which f of x is less than h of x, and then this point as well. Okay, this is the point in which f of x is less than h of x, and then to find them, or to put it in words, in mathematical terms, we know from 0 to a, right? From 0 to a, f of x is less than h of x. Okay, and also we know we have another point. We have 2 points. We know that we have b up to 360, which is b up to whatever the value this is, or from b upwards, f of x is less than h of x. So we're gonna say b x is greater than b. We know that f of x is also less than h of x. Another interesting point, I think we have covered the most important part, which is the same applies. If they said the points in which h of x is greater than f of x, you know, you look for the points in which f of x is underneath. The one that is underneath is the one that we are most interested in. So point in which h of x is greater than f of x, we look at these points, because this is over this graph now at this point. So from 0 to a, and from b upwards, h of x is higher than f of x, and you're gonna put it down. You're gonna write them down once you know the values. All right, thank you guys for watching this. I hope this was very helpful for those trigonometric graphs. In the next video, I will cover the tangent functions. Thank you so much.